Okay, we're going to look at Chapter 3, which is on solving inequalities. Section 3.1, going to be pretty easy. Inequalities and their graphs, and you should have seen all this stuff before, but it's been a couple years maybe for some of you. So, less than, greater than, less than or equal to, and greater than or equal to. So if you don't know those, go ahead and write those down. This is the less than or equal to, this is the greater than, and this is the greater than or equal to. So what we're going to do is we're going to just do some translating here to begin with. Write the inequality that represents all real numbers p greater than or equal to 1.5. So they want us to put p greater than or equal to 1.5. So p, that's the greater than or equal to symbol, 1.5. Boom, that's it. All right, so the next one, write the inequality that represents the sum of t and 7 is less than -3. So now when we see this is less than, we were sometimes used to thinking of that as subtraction. Right now, since we're talking about inequalities, we're looking at that as our less than symbol. So sum of t and 7 means we're adding t and 7, and this is less than -3. That's it. So the solution of an inequality would be any number that makes it true. Any number that's going to work in there for t that would make this inequality true, or any number up here that would work for p that would make that inequality true. So they're going to give us some choices. Is -1, 0, 1, and 3 solutions to this inequality? So if you put -1 in for y, is it less than or equal to 6? So you do the math. 13 plus 7 is 20. 20 is not less than or equal to 6, so -1 does not work. And then you would check the 0. If you put 0 in there, is that less than or equal to 6? 13 take away 0 would be 13. It is not less than or equal 6. We could try the next one. If you put a 1 in there, 13 take away 7 times 1 is 7. So this actually gives us 6. Is 6 less than or equal to 6? Yes. So that is going to work. And then the last one, putting a 3 in there. 13 take away 21 is going to be negative something, so it's absolutely less than 6, so it also works. There will be many, many numbers that work, so just because you find one that works doesn't mean you stop. Okay, you have to check them all on these. All right, here's a little kind of a goofy thing that I've always seen when we are graphing. In order to know whether we have the equal sign with our graph or not, so this is our less than or greater than sign. Whoops, I'm sorry, this is greater than, this is less than. We will have an open circle when we draw the graph. When we have greater than or equal to or less than or equal to, we will have a closed circle when we draw the graph. So let's take a look at a couple of these. X is greater than -4. So think of some numbers that are larger than -4. Well, -3, -2, -1, any of these numbers up here are going to be greater than -4, starting at -4. But do we want to include the point -4? No, so we have to show that by putting an open bubble there, which says we're going up to this point, but we are not including that point. Every one of these points after this is going to work. Okay, C is less than 0. Here's 0. We want all the points that are less than 0, but because it's not equal to 0, we don't want to include the point 0. So we again have an open bubble there. If we have greater than or equal to or less than or equal to, we are going to have a closed-in bubble because we want to include that point. Now, I don't like having the N on the right side of the inequality symbol, so I'm going to flip this around. When I do that, though, I have to keep my point pointing the same direction. So I'm pointing to the 3, I have to keep pointing to the 3, or I'm open to the N, I have to keep open to the N. So N is greater than or equal to 3. Here's the 3, greater than is this way, but because I want it to be greater than or equal to, that means I am including the point this time, so I have to shade my point in. All right, which inequality represents this graph? Now we're going backwards. So we have the points less than -3. So I want my numbers less than -3. It's not equal to because that's an open circle. Now down here, this is a closed circle. So down here, I want the numbers that are greater than 0. So any number greater than 0, but because this is closed in, I want it to be greater than or equal to 0. Next, what inequality describes this situation? We want trail rides starting at 1999. So what inequality would show that we are starting at 1999 and our numbers can be larger than that? Well, trail rides are going to be greater than or equal to 1999. They could be equal to 1999 because that's where they start, but they could also be anything greater than that. All right, 2 more. What inequality does this situation describe? I don't know if I've ever seen an 8-mile-per-hour sign, but if you do see a speed limit sign, that is the fastest you can drive. So we could go slower than this. So our speed could be less than or equal to 8. And then the last one, can the speed be all real numbers less than or equal to 8? Could it really be all numbers less than 8? Well, if you think about that, remember back to when we were looking at restricted numbers, technically you can't have a speed that's negative. I guess maybe in some situations somewhere you could, but for the most part we don't have negative speeds. So we would have the limit of 0. You can't really go below 0. Okay, in other words, no negatives. So what that allows us to do is basically say our speed, yes, it's going to be less than or equal to 8, but it's also going to be greater than or equal to 0. So it's kind of sandwiched in between 0 and 8. And we'll look more at this in another section.